Yeah, when I was only 17, I could hear the...
Hello, students. This is Mr. Ezra. Today we are going to talk about some more polynomial function characteristics, specifically in behavior, and we're going to begin to learn how to sketch polynomial functions once we know some of the characteristics. So let's get started. First off, in behavior, you probably have seen this before, but let's review it just in case you haven't. When we talk about in behavior, we basically want to know what is happening at the two ends of the function. At least for this type of function, that's what we're asking. So we're going to look on the left side of the function and the right side of the function to figure out whether or not the function is pointing up or down, and that's basically it. You have to get used to writing in behavior in this manner. So this is like the Mathenese way to say x arrow in positive infinity, f of x arrow something, x arrow negative infinity, f of x arrow something. This is our kind of like technical way to say as x approaches positive infinity. Well, if you look at the coordinate plane, x approaching positive infinity is on the right. So this is our fancy way of saying when you're looking at the right side, what's happening to y? Since f of x is the same thing as y, is your function going up or is it going down? Up is positive, down is negative. So all we want to know here is up or down, and that's really the answer to the question for in behavior is what's happening on the right side. And then as x approaches negative infinity, as we go to the left on our function, what's happening to the function there? Is it going up or down? And again, we're looking for up or down. So the key to answering in behavior questions is first memorizing how to write it in this fancy way, and then just figuring out whether the function is up or down on the right, and then up or down on the left. So let's look at some examples. Just to make life easier, I've filled in everything that's pretty much going to be the same. I should mention at this point that these two lines of text could be in reverse order. You could have the x arrow negative infinity on the top and the x arrow positive infinity on the bottom. That would be fine. There's no reason that one goes before the other. And also positive infinity can be written without the positive sign. You can just write infinity and that's fine as well. And you'll see it that way. So here, as x arrow infinity, remember that's our way of saying to the right. So to the right means you follow this function to the right, and when you end on the right, are you going up or down? Well, that is up, isn't it? And up is going to be a positive infinity since we increase towards positive infinity up the y-axis and decrease towards negative infinity. On the left side of this function, as we go to the left, as x approaches negative infinity, means as we're going to the left forever. So we go left on the function, it's going down. And down is negative infinity. If you can get used to that, you've got your in behavior on lockdown. That's pretty much it. Okay. Our second example here, again, we've got right. We follow this all the way to the right, and on the very right end, what's happening? It's going up towards positive infinity. And on the left side, as we follow it along to the left, the end is pointing up, and up is positive infinity. And that is it. A few more examples really quickly. Right side, follow it along to the right. We're going down. So right is down. Down is negative infinity. Left towards negative infinity is up towards positive infinity. Example number 4, right side is down. That's negative infinity. Left side is also down. That's negative infinity. Both of them are down. Well, let's think about in behavior based on just an equation. Okay, so there's some things that we need to know about these types of equations and what they look like. And the first thing is when you have an even exponent, or in other words, an even largest exponent, an even degree. both are going to be up or both are going to be down. And we've seen that in examples. You just may not have paid attention to it. But anytime you have an even degree like a quadratic, both ends are up or they're both down. When we have an odd degree function, which means that the biggest exponent is odd, one of the ends is going to be up and the other is going to be down. One of the ends is going to be up and the other is going to be down. Okay. Now, how do we know which of these, once we look at the degree and we say, well, both are up or both are down, well, what we go to next after we look at the degree is we look at the leading coefficient. If the leading coefficient is positive for an even degreed function, they're both going to be up. If the leading coefficient is negative for an even degree function, they're both going to be going down. For an odd degree function, if the leading coefficient is positive, it's going to end up. And if the leading coefficient is negative, it's going to end down. In fact, that's kind of always true. No matter what, the leading coefficient positive ends up, and the leading coefficient negative ends down. Okay, so let's kind of get a really loose sketch of these. We got an even degree and a positive leading coefficient. So even degree and positive leading coefficient. What does that mean? It means that the even degree means they're in the same direction. Positive leading coefficient means the ends are both up. So on the right side, I'm going up towards positive infinity. And on the left side, I'm also going up towards positive infinity. But in our sixth example here, we have an odd degree and a negative leading coefficient. I'm going to put a little negative sign there. Negative leading coefficient. Well, odd means that they're in different directions. And negative means that it ends down. So if they're in different directions and it ends down, the left side has to be up. So if we look at our thing here, as we go to the right, we should see down. As we go to the left, we should see up. And you can graph these on your graphing calculator just to check to make sure that you're getting it right. But that is what would happen. Okay. In our final example, we have an odd degree exponent, odd degree polynomial, largest exponent's odd, and a positive leading coefficient. This means that they're in different directions, but since it's positive, the right side is up. And if they're in different directions, that means the left side is the one that has to be down. So as we go to the right, we're going up towards positive infinity. As we go to the left, we're going down towards negative infinity. Again, you could get your graphing calculator and put this in for y1, check the graph, and see that what's happening at both ends if you get the window set to the right place. So let's look at this thing and let's see if we can figure out what we know about the equation. This is kind of like what we were just talking about in reverse. Well, first off, do you see that one arrow is up and one is down? They're in different directions. So what does that tell us about the degree? That it's odd. Since the right side is up, what does that tell us about the leading coefficient? It tells us that the leading coefficient is positive. We know this, we know these two things just by looking at the picture and using the end behavior. It tells us a little bit about this function. There's probably more that we could get from the graph that we'll talk about later, but right now that's all I want us to focus on is the end behavior from the picture. What does that mean about the degree and the leading coefficient of the function? Right, here's another one. We have both arrows in the same direction. They're both down. Well, if they're both down, that tells us that we have an even exponent or an even degree polynomial function. The right side is down or both sides are down, which tells us that our leading coefficient is going to be negative. All right, we got another example here. Right side is up, left side's down. Since the sides are in different directions, since the ends are in different directions, we know we have odd degree exponent or an odd degree polynomial function. The biggest exponent's odd. Since the right side is up, we know that it is a positive leading coefficient. Remember that the extrema are kind of like all the turns in the graph, all the changes of direction in the graph, and there's a relationship between the extrema, the number of turns in the graph, and the least possible degree of the polynomial. So let's talk about this really quickly. If you are given a graph, for example, we have a graph right here, and remember we just looked at it. We have 1, 2, 3 changes of direction, or 3 extrema. If you take the number of turns, there's 3 turns, and you add 1, you get the least possible degree of the polynomial. So we know that the least possible degree of this polynomial is 3 plus 1, or 4. The least possible degree would be 4. In the opposite direction, if you're given a function, you can take the degree, and remember the degree is the largest exponent, and you can subtract 1 to get the number of extrema, or the most number of extrema, I should say. Most number of extrema. So here we've got 3. That means it should have at most 2 extrema. And that relationship is going to be generally true. You won't have more than 2 extrema for this polynomial function. For the graph on the left, it won't be less than a 4th degree. So what is the least possible degree of the function listed here? Well, we have 2 turns. And with those 2 turns, we add 1. 2 plus 1 is 3. So the least possible degree is going to be 3. All right, another example. Here we have 1, 2, 3 changes of direction, 3 extrema. Remember, you add 1. 3 plus 1 is 4. So 4 is the least possible degree. That's pretty simple, isn't it? Well, we don't have a graph. We can do this kind of process in reverse. So we look to find the degree. And once we have that degree, we're going to subtract 1 to get the highest number of extrema, the highest number of extrema. So 4 minus 1 means that there should be at most 3 extrema. 5 minus 1 means at most there's going to be 4 changes of direction in the graph. And then 3 means a degree of 3 means that there's going to be at most 2 extrema. So we're going to take all these characteristics that we've been talking about and use them to get a sketch of the graph. And let's talk about sketching. Sketching is not perfection. This is not like the best looking graph, but the characteristics that we know should be represented on the graph in some way, and the end behavior should be correct. And so it's going to have some detail, but it's really going to be a very loose sketch. Okay. So for example, in this function, f of x equals x squared plus 8x minus 20, we are given that there are 2 zeros. So if you solve this function, you would get these 2 zeros. Remember, zeros are where the function crosses the x-axis. So we're going to kind of come over to about where we think negative 10 is. And we're going to come over to the right to about where we think 2 is, and just kind of give us some guideline dots there. I know that I'm not putting all of the information. That's okay. It's just a sketch. Now, how many zeros are there? Well, first off, if I don't know how many zeros there are, the degree tells me the number of zeros. So there should be 2 zeros here. And I find out that there are exactly 2. At most 2 zeros. If there's like a double root or something, there could be 2 zeros that are the same. But in this case, they're 2 different zeros. The y-intercept, do you remember how to find that algebraically? You let x be 0, right? And 0 squared plus 8 times 0 minus 20 is negative 20. So we can find the y-intercept from this equation. And that's usually just the constant if you want to remember that, because the zeros for x is going to cancel everything else out. So we're going to come down, a little ways and say, well, here at -20, we know our function goes through there as well. Okay. Now let's talk about end behavior. Our degree is even and our leading coefficient is positive. That means that both of our ends are up. Both ends are up, right? Going towards positive infinity. So I know that on the right side I'm going to end up, and I know on the left side I'm going to end up. And I'll have to think about that as I begin to sketch my function. I also have this thing called extrema. Remember, extrema is the degree minus 1, and it's the number of turns in the graph. So there's going to be one extrema in this graph. We changed colors here. I know that I have a quadratic. I know that it starts up, it comes down, and it goes back up. And since there's only one turn, I'm just going to come down, come back up, and have an arrow at both ends. I go through my two zeros at -10 and 2. I go through my y-intercept at -20. Is this the only way that it could look? Well, your sketch might look a little different, but it should look kind of like this. It's fairly similar. That's the idea. Is we want to know what the function looks like in general terms. Here we have a third degree polynomial function with 3 given zeros. So we know that we have 3 zeros, and they are given to be -2, -1, and 1. So I'm going to go over here, here, and here to just give myself -2, -1. That's going to be 0 right there, and then +1, some guidelines. The y-intercept is going to be the constant here, -2. So I'm going to come on the y-axis down to about -2, about right here. Okay. In behavior, looking at my function, it is an odd degree and a positive leading coefficient. So the arrows are in different directions, and the right one is up because of this positive leading coefficient. So the right side, as x approaches positive infinity, is up, and the left side, as x approaches negative infinity, is down. And the number of potential extrema, the most number of extrema, is the degree minus 1. 3 minus 1 is 2. So it's going to have 2 turns in direction. Essentially, it's going to look something like starting at the bottom, 1 extrema, 2 extrema, and ending going up, something like that. And we've got to fit that onto our dots here that we've got on our graph. So we're going to start at the bottom and go up through this first one, and then down, and then back up. And we don't know exactly what it looks like, but this is a pretty good estimate of what our function is going to look like. It's going to start at the bottom left, it's going to go through those zeros and through that y-intercept, and then end going up at the right. Well, that is it for today. I hope that what we've talked about makes sense to you, and remember that you can always ask questions in class if something isn't quite clicking with you.